Welcome back to my class. We know that in exam questions based on objective type and true false come. So this type of question also has equal importance and we should learn that how to answer them correctly and first. And that's why today's class will be based on objective type questions related to the concept that you have learned so far in my earlier classes based on rational numbers. So without wasting time, let's get started. The first question, it says the product of a positive rational number and a negative rational number is always dash. That means what will be the answer? Now say for example, if we take a simple example of a positive rational number means plus 2, and a negative rational number, we will take another simple example of negative rational number, and that is minus 3. So if we multiply them, then what is the result? Minus 6. So that means the product of a positive rational number and a negative rational number will be always negative. The answer here is in terms of sign, whether it will be positive or negative. So here the answer will be negative. Here I have taken simple examples in terms of integers. You can take example in terms of fraction. It could be proper, it could be improper. Whatever example you take, the answer will be always, the sign of that product will be always negative. Now the second question, it asks that 0 has dash reciprocal. We know that if suppose 0 is the rational number and we know the reciprocal is what? Reciprocal is 1 upon that number. So 1 divided by that number means 0, and when something is divided by 0, that is basically infinite, or we say that is undefined. So if we divide 1 by 0, that means if we take the reciprocal of 0, that is undefined. So here the answer will be 0 has no reciprocal, and that we have already learned. Now the next question is the product of a rational number and its reciprocal is what? Suppose if the rational number is a, that means the reciprocal will be of that rational number, it will be 1 upon a. So if it is a and 1 upon a, then the product of a and 1 upon a, that will be always 1. That means whatever rational number we choose, integer, positive, negative, proper fraction, improper fraction, and if we take the reciprocal of that rational number and if we multiply both the numbers, then the result of that product will be always 1. So here the answer will be 1. The product of a rational number and its reciprocal will be always 1. So just remember that. Now the next question is about the numbers. This dash and dash are their own reciprocals. So this also we have already learned that if the number is 1, then the reciprocal of 1 is what? Reciprocal of 1 is 1 divided by 1. That means 1 only. And again, if we choose another rational number minus 1, then also we know that reciprocal of minus 1 is how much? It will be 1 divided by minus 1, and that means it is minus 1 only. So these are the two rational numbers whose reciprocals are the same numbers only. So reciprocal of 1 is 1. So the first answer will be 1 in this under this first dash, and the second rational number will be minus 1. So 1 and minus 1 are such rational numbers whose reciprocals are the same numbers only. Now the next question is the number 0 is dash the reciprocal of any number. So any number, it is suppose a, any rational number, then the reciprocal we represent as I have written already, that it is 1 by a. So that means the reciprocal of 1 by a will be a, we can say. Now here the question is the number 0 is reciprocal of which number? That means if 0 is the reciprocal of any rational number or f of any number, then the original number will be 1 divided by 0. That means reciprocal of the reciprocal. So here, as we know, as we have already seen in one of our earlier questions, that when we divide anything by 0 that is not defined, so we cannot divide anything by 0. That means 0 cannot be reciprocal of any number in the number system. So we can here write, the answer will be the number 0 is not the reciprocal of any number. So here the proper answer will be not. 0 is not the reciprocal of any number. Now the sixth question, it is related to the rational number minus 3 by 5 lies on dash of 0 on the number line. Now we know on the number line, if we choose any point at the center and that if we assume that as 0, then on the right if we move, then that basically represents the positive number, so on the right side of the number line. And on the left side of the number line, if we move towards minus infinity, then that represents all the negative numbers on the number line. That means here the question is minus 3 by 5, so it is a rational number and it is negative. So since it is a negative number, definitely it will lie on the left side of 0 on the number line. So here the proper answer will be the rational number minus 3 by 5 lies on the left of 0 on the number line. Now the next question is multiplication of rational numbers is dash over addition. Now we have already learned various properties of multiplication of rational numbers, and there we have seen that there is a property called distributive property, and distributive property, it says that multiplication is distributive over addition and subtraction. Suppose if we have two rational numbers a and b, and if we add them, and with the result of that addition, if suppose we multiply by another rational number, then the result will be here ac plus ab. So here the multiplication is distributive over addition. Now the same thing can happen in case of subtraction as well. So if two rational numbers, if we choose a and b, and first if we subtract one rational number from the other one, and then with that result of subtraction, if we multiply by another rational number, then it will be nothing but AC here minus AB. So multiplication is distributive over addition and subtraction, but this question is related to addition. So here the multiplication of rational numbers is the proper answer will be, the correct answer will be distributive over addition. Now the next question is rational number which is negative improper fraction. So we have to give an example of rational number which is negative and improper fraction. Now improper fraction, we know that where in case of fraction where the numerator is greater than denominator, like 5 divided by 2, it could be 9 divided by 5. So in these examples the numerator is greater than denominator, or any integer here also, like if we take 7, that means 7 is what? 7 divided by 1. So all these are improper fraction where the numerators are greater than denominators, and we have to take negative improper fraction. So with all these numbers, if we add negative sign, then they will be the examples of negative improper fraction. So we can choose any of them. So suppose if I choose minus 5 by 2, then this is a good example of negative improper fraction. Let's move on to the next question. It says the subtraction of two rational numbers is not what? Dash. So here basically it is related to the properties of subtraction. So we know that rational numbers are closed under subtraction, so it obeys the closure property, but in case of subtraction it doesn't obey associative and commutative property. So since here it is not, so we have to focus on the properties which are not obeyed by subtraction of rational numbers. So we know that commutative property, what it says, that if we choose two rational numbers a and b, or maybe a by b and c by d, so if we subtract c by d from a by b, then that will not be equal to when we will subtract a by b from c by d, and that we have proved in our class where we learned about the subtraction, different rules and properties. And also we have the associative property, where we have learned that if suppose we choose three rational numbers, say a by b and c by d, and first if we subtract the second rational number from the first one, and from that result of subtraction if we suppose subtract the third rational number, then that will not be equal to when we will subtract the third from the second first, and then that result will be subtracted from the first rational number. These two are not same. So we know the subtraction of rational numbers doesn't obey commutative and associative laws or properties. So here the answer will be subtraction of rational numbers is not commutative. Either commutative we can write or associative we can write. So anything will be correct. The next question asks about how many rational numbers are there between two rational numbers. And we know that between any two rational numbers there exists infinite number of rational numbers, and we have already discussed in one of our earlier classes. We have solved numericals based on that. So here the answer will be infinite. So infinite number of rational numbers are possible between any two given rational numbers. The next question is non-terminating dash rational numbers are rational numbers. Now we know that rational numbers are those numbers which can be expressed as a ratio of two integers. This is the first question. This is the first criteria or condition. The second condition is q, the denominator should not be equal to 0, otherwise that rational number will be undefined. The third criteria is it should be expressed as a decimal number. The rational number finally should be expressed or simplified as a decimal number. Now this decimal number either will be a terminating decimal number, like if we take example as 0.5, 0.5 is basically the decimal form of this rational number 1 by 2. So 1 by 2 can be expressed as 0.5. So this is terminating decimal number. Now second example is say 1 by 3. 1 by 3 can be expressed or can be simplified as 0.3333 and so on. So it can be expressed as 0.3 and bar. So it is a recurring decimal number, or we say this is a repeating decimal number, and this is not non-terminating in nature, because this will continue, this 3 for this example, this 3 will continue till infinity. Now if we take another example as root 2, then root 2 if we expressed in decimal, then it will be 1.414, then it will be 21356 and so on. Here the digits after decimal point, they don't recur following any fixed pattern. So here this root 2 is an example of non-terminating decimal number, and as well as this is an example of non-recurring decimal number. So in the previous example this was non-terminating, but it was a recurring decimal number, and here this is also non-terminating but non-recurring decimal number. So 1 by 3, since this is recurring decimal number even though it is not terminating, so this can be taken as a rational number. But root 2, since along with non-terminating this is also non-recurring decimal number, so this cannot be considered as a rational number. So the numbers which are non-terminating as well as non-recurring, these numbers cannot be considered as rational numbers. So here the proper answer will be non-terminating and recurring decimal numbers are rational numbers. So it will be recurring. The next question starts with dash. Dash is not a rational number, and within bracket is written example. So we have to give an example of a number which is not rational in nature. So as we have discussed that root 2 is an example of irrational number. Similarly, root 3 also an example of irrational number. We know that pi is also an example of irrational number. Now the next question is division of two rational numbers is or is not always closed. We know that division of two rational numbers, suppose if 8 is a rational number, we know, though this is a positive integer, and 2 is also a positive rational number. Now if we divide 8 by 2, then the answer, the quotient will be 4, which is also a rational number. So if we divide a rational number by another rational number, the quotient, the result of that division will be always a rational number. But there is an exception, and that is if we divide any rational number by 0, then that is not defined. So we cannot, as we know, we cannot divide any number by 0, be it rational or irrational number. That means division of two rational numbers, we cannot say that this division or the rational numbers are always closed under division. No, they are mostly closed under division, but there is an exception that when a rational number is divided by 0, so that is not possible. So that means we cannot say that division of two rational numbers is always closed. So here the perfect answer will be, the correct answer will be is not, because the 0 is the exception, and for that the answer will be is not. So division of two rational numbers is not always closed. Now the next question is about multiplicative inverse of reciprocal of 7. So first we have to see that what is the reciprocal of 7. Reciprocal of 7 is, if 7 is the number, then reciprocal will be 1 by 7. And then we have to find multiplicative inverse of that reciprocal. So multiplicative inverse means 1, then 1 upon 7. So first we have obtained the reciprocal of that number, which is 7, and so the reciprocal is 1 upon 7, and then multiplicative inverse, so 1 upon 1 by, or 1 upon 7, so finally it will be 7 only. That means multiplicative inverse of reciprocal of any number is that number itself. So if the original number is 7, then reciprocal, multiplicative inverse of reciprocal of 7 will be 7 only. So with closed eyes we can always answer, if this type of question comes, then the answer will be that number only. Now the last question is, dash is not a natural number but a whole number. We know that what are the natural numbers? It starts with 1, 2 and so on, it continues. Now if with that, if we add 0, then that set of number becomes a whole number. But 0 is not a natural number, but it is a part of whole number. So here the right answer will be 0 is not a natural number but a whole number. So the answer will be 0. So this class was about the objective type questions that frequently come in examination. So we should be well prepared for this type of questions. I hope you have learned and enjoyed this class. Thank you.